Okay, so in this section, lesson 4, we're going to use the product rule to find the derivative of a function and then use the quotient rule. If we have time, we'll also look at finding higher order derivatives. Now, I've told you in the past that if you were multiplying two functions together, you can't just find the derivative of the one and the derivative of the other and then multiply them together. If you are multiplying two functions together, you have to use the product rule. And the product rule basically says this: you keep the first function the same, and then you multiply by the derivative of the second function. So you keep f of x the same, and you take the derivative of g of x. And then you add that to keeping g of x the same, and then take the derivative of f of x. Okay? That is the product rule. Now, we could multiply this through and then find the answer. You get the same thing. Or we could use the product rule. So let's try using the product rule. So we're going to find the derivative of f of x, the first thing we want to do is keep 6x plus 5 the same. And then take the derivative of x cubed minus 2, which is 3x squared. Then we keep x cubed minus 2 the same and take the derivative of 6x plus 5, which is simply 6. Now, where you go from this depends upon your teacher and whether or not it's multiple choice question. You will have to ask your teacher in the fall how far does she want you, he or she wants you to simplify. I would probably suggest just doing a basic level simplification. So we get 18x cubed plus 15x squared plus 6x cubed minus 12, and then combining like terms would give us 24x cubed plus 15x squared minus 12. Okay? For this one, we want to do the same thing. We could multiply, we could distribute this and find the derivative, or we could use product rule. Let's do the product rule. So we have f prime of x. We're going to keep radical x the same and take the derivative of 4 minus x squared, which is negative 2x. Then we take the derivative of radical x. Now remember, this is one that I kind of advise you to memorize. We could use the power rule, which is 1/2 x, and then subtracting 1, we get negative 1/2, and then we keep 4 minus x squared the same. Or we could just know that the derivative of this is just 1/2 square root of x, which is probably what I would have done. So once again, how much you simplify just depends upon your teacher. So I would probably say this becomes, remember x, this can be written as x to the 1/2, so this is going to give us negative 2x to the 3/2. And distributing the 1/2 here, we get 2x to the negative 1/2, and then minus 1/2 x to the, what is this, 4/2, so 3/2. Okay. Alrighty. You want to pause this and see if you can't do it on your own. It's basically the same thing. We keep the derivative, we keep the square root of x the same, and then the derivative of sine x is cosine x, and then we keep sine x the same, and we take the derivative of this, which is 2 over the square root of x, and that's it. Same thing for e to the x and natural log of x. We keep e to the x the same. The derivative of natural log of x is 1/x. Then we keep natural log of x the same and take the derivative, I don't know why I wrote that, the natural log of x times e to the x. So that is the product rule. Again, you would pause this and just do it on your own. But basically, we do the exact same thing. This is almost just like the one we just did. We keep natural log of x the same. The derivative of cosine x is negative sine x. Then we keep what do we do? We keep cosine x the same and take the derivative of natural log of x, which is 1 over x. We keep e to the x the same, take the derivative of cosine x, which is negative sine x. And then we keep cosine x the same and take the derivative of e to the x, which is e to the x. Now, the quotient rule is a little bit more complicated, but it's basically the same thing. If I have f of x divided by g of x, it's g of x times f of x prime minus f of x times g of x prime all over g of x squared. And there's a mnemonic device to help you remember that. Low d high minus high d low over low squared. So we take the low and we multiply times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And so this is just a mnemonic device to help you with that. Low d high minus high d low over low squared. Now, especially for these, we're not going to spend a whole lot of time simplifying, okay? So the derivative using our little mnemonic device is low times the derivative of the high minus high times the derivative of the low all over low squared. And you never ever want to waste time multiplying out that denominator. We could possibly simplify the numerator. And then, of course, we could combine 4t squared minus 2t squared and get 2t squared minus 14t minus 4 over top all over 2t minus 7 squared. But we never want to take time to multiply that out. Okay? So once again, we do low times the derivative of the high minus high times the derivative of the low. You see why I suggest that you just memorize this one? Because we see it all the time, all over low squared. And really for that, I would probably just leave it just like that. I wouldn't simplify any further. You want to try another one? You want to pause it and see if you can do it and then come back and see the answer. That would be a great idea. But we're going to do low times the derivative of the high minus high times the derivative of the low all over low squared. Okay? All right, when you're doing this one, you have to remember that these are constants. And the derivative of a constant is 0. Even though it's called c squared, it's still a constant. So we're going to take low times the derivative of the high. Because c squared is a constant, its derivative is 0, so that just be negative 2x. Low times the derivative of high minus high times the derivative of the low. Once again, c squared is a constant, so this would be 2x all over c squared plus x squared quantity squared. And we do not want to multiply that out. We don't want to waste time multiplying that out. Now we could probably do something with the top if you are so inclined. We could have negative 2c squared x minus 2x cubed minus 2c squared x plus 2x cubed and then some simplifying could be done there probably. What you want, if it's multiple choice, you want to get it to look like the multiple choice. If it's free response, you want to just take the derivative and move on with your life. Okay, I just want you to call some basic derivatives. Remember, the codes are always negative. And you just have to memorize these. There's just no getting around it. You just have to memorize it. Oh, wrong way. Okay. Alrighty. So again, we're going to use the quotient rule, and we're going to memorize the functions that we just learned. So the derivative of secant x is secant x tan x. So we have low times the derivative of the high minus high times the derivative of the low, so the derivative of x is 1, all over x squared. And yeah, we could probably factor some things out. Okay, so what's the derivative of cosecant? We know it's negative, and the derivative is negative cosecant cotangent. So now we're using the product rule. So we keep the first one the same. We take the derivative of cosecant, which is negative cosecant secant, or negative cosecant cotangent. Now I don't have them memorized, but guess what? I don't have to take the AP exam. So, and you do, and so you need to memorize them. Cosecant cotangent x. So we kept the first one the same. We took the derivative of the second one. Plus, we keep the second one the same, and we take the derivative of x plus 1, which is 1, and that is our answer. And I need to be better about my notation. F prime of x is equal to that. Again, we have to use the product rule, and we have to use the product rule twice. Now, what I want you to notice is that you do not have to use the product rule on 5 because it's a constant. So we're going to treat it like a constant. We can do it one of two ways. We can take 5 out of, just take it out. And so we keep x the same. The derivative of secant x is secant x tan x plus we keep secant x the same and take the derivative of x, which is 1. So then this would just be secant x. And remember, all of that's multiplied by 5. And then we do the same thing here. We keep x the same. The derivative of tan x is secant squared x plus tan x. And that's our answer. Okay? Again, product rule. X stays the same. The derivative of cotangent x is negative cosecant squared x plus we keep cotan x the same and then take the derivative of x, which is 1. Now, this is very important. The AP exam loves to give you tables to work with, okay? And again, your temptation is just going to say, okay, find the derivative of f of x, find the derivative of g of x, and multiply them together. But that would be wrong. So we have to remember that this is going to be, we're finding the derivative at 3, so this is going to be f of 3 times g prime of 3 plus g of 3 times f prime of 3, because we still have to use the product rule on this, okay? So using our handy-dandy table, f of 3 is 7, g prime of 3 is negative 1, g of 3 is negative 4, f prime of 3 is 3/2. So this is negative 7 minus 6. So this is negative 13. Okay? So your temptation is just going to say, okay, f prime is 3/2, g prime is negative 1, the answer is negative 3/2. That's going to be your temptation. Fight the temptation. You have to use product rule. And here you're going to have to use quotient rule. So here we're going to have to say the same thing that we did before. Low D high minus low D high minus high D low all over low squared. Okay? So using our handy dandy table, g of 1 is 2, f prime of 1 is 5, f of 1 is 4, g prime of 1 is negative 1/2, all over g of 1 squared. So that's 10 plus 2 over 4, and that is 3. Okay? So be very careful with that. Here's some problems for you to try. And once again, the answers are in your packet. Oh, by the way, there are the answers right there. Number 47, we have to use chain rule, which we don't know chain rule yet. So you can't do 47 at this point. But you should be able to do the rest of those, so pause it and try it, and the answers are here. Okay, one last thing is to take higher order derivatives. And it's basically, you just keep taking the derivative until you can't take it anymore. So the notation is what you need to know. Sometimes it's written like this with 2 primes, so this means the second derivative. So you see it like this and you see it like this. You very rarely see it in this form, but you normally see it with the primes, or sometimes you'll see d squared. And as you get to the higher ones, you might see y triple prime, which just means the third derivative. But after a while, we start to write them like this. And we see this a lot when we get to BC. So basically, you just need to know the notation. And then to take the third derivative, you just take the derivative the first time. And then you take it the second time. And then you take it again. That would be negative cosine x. And that's the third derivative. And that's what this means. Find the third derivative. They want us to find the fourth derivative. So we find the first derivative. It's 12. Using the power rule, we get 12x squared minus 6x plus 2. And then we do it again. We get 24x minus 6. And then we do it again. And we get 24. And then we do it again. And we're going to get 0. So we would say this function is fourth differentiable, because after the fourth derivative, it just becomes 0. Again, we're going to do the same thing. Using our handy-dandy rule that we know, we're going to say that this is 1/2. I'm just going to write an x to the negative 1/2, just because that's easier. No, it's multiplied by 2, so it wouldn't be 1/2. It's just going to be x to the negative 1/2. Sorry, because it's already multiplied by 2. So then the next derivative would be negative 1/2 x to the negative 3/2. We're subtracting 1 each time. So then the next derivative would be 3/4 x to the negative 5/2. And then the fourth derivative would be negative 15/8 x to the negative 7/2. And taking multiple derivatives become really important when we get to Taylor series in Calculus BC. Okay, that's it. So we want to find the derivative by using product and quotient rule, and then take higher order derivatives. That's what you should have gotten out of this video, and I hope you did. I think you have some practice problems to do. Thank you.